Hey students, in this video we're going to cover the Unit 3 study guide. So let's get going. All right, so for these graphing problems, we need to find all of those key elements. So let's start by finding the, let's start by, let's start by factoring the numerator. So we're going to get x minus 4 times x plus 2 divided by x plus 3 times x plus 2. So we know that when the factor cancels, we have a hole at the place where the of the cancel factor. So we have a hole at x equals -2. The actual coordinate is -2, and you go back and sub -2 into this remaining function. If we substitute in -2, we get -6 divided by +1, which is -6. And so then we have a vertical asymptote at x equals -3. We have a horizontal asymptote of y equals 1 because the ratio of these leading coefficients is 1. We have an x-intercept at 4, 0. We have a y-intercept at, if we substitute in 0 for x, we get 0, -4/3. And that is it. We can make a little sign chart to know where our graph should be positive and where it should be negative. On that sign chart, we put our vertical asymptotes and x-intercepts. So we're going to put -3 and +4. Remember, we alternate signs if the factors do not have even multiplicity. So if we choose some value between -infinity and -3, we're going to get a negative divided by a negative, which is going to give us a positive. And so then we alternate signs because neither the factor x plus 3 nor the factor x minus 4 are of even multiplicity. So let's graph our vertical asymptote. That is going to be here, x equals -3. We have a horizontal asymptote at y equals 1. And we're going to plot our hole at -2, -6. Get a hole right here. X-intercept at 4, 0, and a y-intercept at 0, -4/3, which is like -1 1/3. So we'll say the y-intercept is right there. So we have a lot of information to draw the right side of this graph, the lower portion. So remember that here we have a vertical asymptote. So we're just going to write on each side of the -3 what we're approaching. So when x is slightly greater than -3, we're going to approach -infinity. And when when x is slightly less than -3, we're actually going to approach positive infinity when we go toward the asymptote. So that means that our graph is going to look something like this. Something like that. Smoother, but something like that. Let's try again, Mr. Moran. So it looks something like this. And then we don't actually have any points in this upper part here, in this region, like right here. So what we're going to do is just plot one point. I would say choose x equals -4. If x is -4, so we're going to have the point -4, and then -4 minus 4 is -8. -4 plus 3 is -1. So -8 divided by -1 is 8. So the point -4, 8 is on that graph. And so is the point, we use I guess we could use -5 too, actually. So if x is -5, we're going to get -9 divided by -2, so 4.5. So when x is -5, we get 4.5. So that's enough to draw the basic shape of this graph. That should be something like that. All right, so that's the first graph. For number 2, we're going to do something similar, but in this case, before we get started factoring, we can just find the horizontal asymptote. We have x cubed divided by x cubed. So the horizontal asymptote is the ratio of the leading coefficients, which is 2 divided by 1. So the horizontal asymptote is 2. Now we can factor this, and we're going to factor this by getting 2x squared times x minus 4 divided by x. And so if we factor this, it's going to be x squared minus x minus 2, and x squared minus x minus 2 factors to be x minus 2 times x plus 1. And let's see. So now we can cancel out an x here. So this cancels, and that totally cancels. So that means x equals 0 is not a whole because it still remains in the numerator. So our vertical asymptotes are the places where the denominator is 0. So that is going to be not y equals, Mr. Martin. It's going to be x equals 2 and x equals -1. We're going to have an x-intercept at 4, 0, and we're going to have another intercept at 0, 0. So then the y-intercept, anytime 0, 0 is your x-intercept, 0, 0 is also going to be your y-intercept. So next we have vertical, horizontal, x-intercept, y-intercept. Oh yeah, we can make our little sign chart. Let's see, we're going to put on our asymptotes. So we're going to go from left to right. So we got -1. We have an x-intercept of 0, a vertical asymptote of 2, and another vertical asymptote, intercept of 4. Let's clean this up a bit because we're going to need the room. All right. So when x is between negative infinity and -1, we would get, so we're going to have a negative time, if x equals -2, for instance, we're going to have a negative times a negative divided by a negative times a negative. So that's going to be positive. And again, we're going to alternate signs. So positive, negative, negative, positive. And our asymptotes are -2. -1 and +2. So when we approach -1 from the from the left, we're going to go to infinity. We approach -1 from the right, we're going to go to -infinity. 2 is the other asymptote, so this is going to go to +infinity. We'll approach from the right, we'll go to -infinity. So that's all we need. So let's plot all of that information. So x equals 2 is a vertical asymptote. And x equals -1. Go ahead. X equals -1 is another asymptote. That sound you hear in the background is the Keurig going in we'll say dining room. Let's see. Next, we have a horizontal asymptote of y equals 2. So let's put that in there. So let's see. We need to graph the point 4, 0. So that's going to be here. The y-intercept is 0, 0. That's going to be there. And let's see, what else do we need? If we substitute, let's get 1 point in this region, in that upper left region. So if x is -2, if x is -2, we would get -4 times -6. We would get 6. If x is -2, we're going to get 6. And that's just so we can have 1 point that helps us draw this graph. Remember, all rational functions are most rational functions are going to behave where they approach asymptotes. We're going to draw the next part of our graph like this. And so from -infinity to -1, with -0 to 2 is positive. From 2 to 4, the graph is negative. And then from 4 to infinity, the graph is positive. So that's what we need here. Look at that, red, white, and blue. True patriots. All right, number 3. We have f of x equals x cubed plus x squared minus 12x. All right, so this one actually has an oblique asymptote. So let's find that oblique asymptote first. We know it has an oblique asymptote because we have x cubed in the numerator and -4x squared in the denominator. So let's find that oblique asymptote. We're going to do long division. So -4x squared minus 4x plus 8. And that's going to divide into x cubed plus x squared minus 12x plus 0. And -4 is going to divide into -4x squared is going to divide into x cubed -1/4 x times. So -1/4 x times -4x squared is going to give us -x cubed. And then we just distribute to the other two terms. So that's going to get us plus x squared and minus 2x. But of course, because it's division, we do the opposites. So we end up with 0x cubed. 0x squared is the more important one. So -4x squared goes into 0x squared 0 times. And so for a oblique asymptote, you always have a value times x plus a y-intercept. So in this case, our oblique asymptote, or OA, is y equals -1/4 x. So we can actually plot that. So it's here. So we go down 1 and right 4, down 1 and right 4. So it's going to be these points. So our oblique asymptote looks something like this. Mr. Moore, you cannot draw a straight line to save your life. Whew. Oh, that's because for that the second part I went up 2 and over 4. Mr. Moore, you tripping. So, excuse me. So we need to go up 1 and over 4. So here, yeah, that's going to make a nicer line because it's actually a line and not like some weird curve. All right, so that's our oblique asymptote. Now we can factor this thing. We get x times x squared plus x minus 12 divided by, factor out a -4, so x squared plus x minus 2. And that is going to factor more to be x times x plus 4 times x minus 3 divided by x plus 2 times x minus 1. And let's see, we can cancel out a nothing. So our vertical asymptotes are x equals, I'm sorry, I forgot the -4. So x equals -2, and x equals 1. The x-intercepts are 0, 0, -4, 0, and 3, 0. Again, anytime 0, 0 is your x-intercept, that is also your y-intercept. So let's plot all of, you know what? Let's make our number line. We'll make that up here where we have space. You know what? You want to have as much space as I want. So let me take out this long division stuff so I can put the number line here. All right. That line is a little crooked. You know, Mr. Martin's saying nobody's perfect except for Rihanna. So let's actually draw a straight line here, kids. So I don't know if you knew you could do this with the Apple Pencil, but you can. Take that ruler off. So now we can plot our first x-intercept is -4. Then we get -2. And then we have 0, 1, and 3. So if we choose some value less than -4, we're going to get negative times a negative times a negative. Remember that -4 is in the denominator, so we're going to have a negative times a negative times a negative. So 6 negatives actually makes a positive. So again, we just alternate signs. So from -infinity to -4, the graph is positive. So now let's plot our asymptotes. So our vertical asymptotes. So we have x equals -2. Get that. We have x equals, what's the other one? I can't see. X equals 1. It is right here. And let's see what else we need to plot. The x-intercept of 0, 0. That's right here. The x-intercept of -4, 0 is right here. The intercept of 3, 0 is right here. We have a y-intercept. We don't have a horizontal asymptote. So I would say on each interval, let's plot a, let's see what happens at these vertical asymptotes. So at x equals -2. So when we approach -2 from the left, we're going to go down to -infinity. And when we approach -2 from the right, we're going to go up to +infinity. So then at x equals -4, nope, x equals 1 is the other asymptote. So when x is approaching 1 from the left, from the left, we're going to go down to -infinity, and approaching 1 from the right, we're going to go up to +infinity. So your graph should approach the asymptotes. So the oblique and the oblique asymptote and the vertical asymptote when you go to infinities. So first part of this graph is going to look something like this. I'm going to like round out like that. And then is there one more point we can put in between -2 and 0? Let's do x equals -1. So when x is -1, we're going to get -1 times -3 times -4 divided by -4 times -3 times -2. So that seems like it's 12 divided by 24, which is a half. So when x is -1, we get a half. So like that. So you can imagine this graph does something like this, because we have to approach +infinity when we approach -2 from the left. And then we know -4 zeros on the graph. If x is -5, are we going to get crazy values? We would get negative. So if x is -5, so x equals -5. That's going to give us -5. I'm plugging this into the factor version. -5 times -1 times -8 divided by -4 times -3 times -6. So that is 40 divided by 24 divided by, so at 40 over 72, and 8 divides into both of those. So that's 5/9. So that's slightly greater than a half. So x is -5, we get that. So our graph should look something like this, something like that. We can check the answer key actually to see exactly what it should look like. It's not perfect. Yeah, we basically got it. But it looks something like that. All right. So that's going to conclude this part of the video. In the second part, we're going to do the equations